We already have our next speaker on screen. Welcome. I honestly have no idea how to pronounce her name, and I'm too afraid to say it wrong. Could you help me?
Yeah, hi. The German pronunciation is Anja.
Would have said it wrong. So yeah. Okay, we will talk about when, why, and how you can get out of a monolith, right?
Exactly. That's my plan.
Okay, let's do that. The stage is yours, and I want to remind the audience, both online and live here, to get ready and set your questions early so I can use our time for the best. Okay, stage is yours.
Cool. Thank you. Yeah, thanks for having me. What I would like to do today with you is actually not talk about code. Most people love talking about code. That's why we're at a developer conference. But I think if you want to talk about code of a monolith, there is stage 4 with somebody else who's more into the coding details of how to get out of a monolith. What I want to do is something actually I think is even more important today. It is how to convince your manager that you need to get out of it and that you are actually allowed to code. So that's my agenda for today. What I would like to do is, what is actually a monolith? The title is Get Out of It. So what is it? Part 2, when do you want to get out of it? When not? Part 3, I already promised. I would like to help you on the question that might come up, why should I invest money in your request for change? Like, people might ask you, and you probably need to have an answer here. Number 4, at least a rough idea, given that you want to get out of a monolith and that you are allowed to get out of it, how to do it. And in the end, I want to show you a quick real-world example. So let's go. First question. Okay, everybody heard the term monolith, but what is actually a monolith? I wanted to start my talk with a definition. Yeah, and where do you go for definitions? You always go to Martin Fowler. So I had a look at what is Martin Fowler telling about monoliths, and I found a super simple answer. Monolith is a single logical executable. The problem with that definition is it's super precise, and it even helps you a bit with any changes to the system involve building and deploying a new version of the application. Okay, got it. But here we go. If this is a monolith, how do you want to get out of it? What is the alternative? Because if you split a single logical executable, you have 2 or 3 single logical executables. So you have 3 monoliths afterward. So by this definition, actually, the whole talk is over now. It doesn't make sense. Obviously, that's not the full answer. So I had another look. Next try, what are the monoliths? And the next sentence is once again Martin Fowler. The term monolith has been in use by the Unix community for some time. It appears in the art of Unix programming to describe systems that get too big. And here we go, the last part, that's what we want to talk about. A system that is getting too big. And too big, that is not a precise definition, sure not, but it is something that we can now talk about. So if something is too big, then it should be smaller, super easy from the term. So we're searching for a sweet spot in size. So please have a look at that diagram because it will stay for quite some time. So we're talking about the size of executables. And there are extremes, like a big one that is too big, seems to be called monolith. There's the other extreme, small things. There's this word of nano service around if something has gotten too small. Somewhere in the middle, there is the term that everybody's talking about for 20 years. It's microservice. I didn't dare to put it somewhere because I have no idea if it's closer to a monolith or a nano service, and it's hard to put it at the right space. So I didn't put it there at all. Okay, we've learned Monolith is too big. If Monolith is too big, there's probably a problem behind that we tell it's too big. And there's a sweet spot that is not on the extreme side, but somewhere more on the left. By purpose, I didn't put any graph on how big is an executable, but somewhere there seems to be the sweet spot and the gold. And on the right side, there are 3 arguments that I want to walk through with you when something is too big and not the sweet spot. And this is about the scalability of executable, about the ownership, and about the build and deployment frequency. So let's get into those 3. Those 3 might actually be your arguments when your code has gotten too big. Let's go for the first one, scalability. Okay, what's the topic here? It's actually, if there's super big code, you cannot just scale a small part of it. You can just scale the whole big code. And most of the time, it's more expensive to scale the whole thing than to just scale the small parts that you originally wanted to scale. So this is about money. And interesting part here, what happens if it's about money? People try to avoid spending money. So they try to optimize instead of scale. Like if I optimize my code good enough, then I don't have to scale. Makes sense. But where's now the line between I have optimized and I have over-optimized my code? So there is a big tendency, if something is too big, that people start over-optimizing and spending a lot of time or money here. Might be not worth it, actually. Second topic is more about ownership. So everybody with Agile has heard ownership. Everybody wants that teams own code. For me, there are 2 perspectives in ownership. One is people owning code. And actually, I don't see a big reason why people shouldn't own code in a monolith. It's totally fine to own your package or whatever and feel responsible for it. You can do the maintenance and everything. No problem on that part. It might be a bit harder if it's a super large code base and you need to synchronize with other teams. Yes, but it can be done. The more interesting part of ownership for me is autonomy, because for autonomy, you need a bit of independence. One example, if you as a team or person find out you have a problem, you want to release stuff, it would be great to be able to release stuff. So that would lead to actually being able to decrease your lead time for a needed change. Another thing, if I find out what I want to do can be done better with a different tool, this is hard to do in a super large code base. So you're actually bound to tooling decisions and process decisions that are not perfect for your use case because you're in a bigger thing. What does it lead to? It's harder to choose the best tool, so probably the development time increases, and once again, the lead time for change is higher than it would need to be. Another part is it's hard to feel responsible for the business part of a small part of a huge monolith. It's very hard because you cannot actually influence all parts. So other way around, if you feel responsible, you want to have good monitoring on your business part written in code. And if you would have that, it would actually lead to you being able finding problems earlier. And for example, decreasing time to restore services in case of failures and catastrophes. Just one more thought on if you would have the feeling of full ownership for your part on the whole business part, like really owning the business KPIs as a team. From my perspective, it also leads to increased domain knowledge. And with domain knowledge, I don't mean I know this and that line of code perfectly well. It's more, I know the customer impact and what part of my code and my service is actually important to the customer and to the business. And if you know all that stuff, the risk of doing customer critical mistakes decreases a lot. Okay. 1 second, then we go to the next part. So there's one more part about Monolith that I have lived with for years now. And this is about the build and the deployment frequency of big code bases. There's one tendency. It's not 100% of the time true, but most of the time it is actually true that a huge code base leads to slower builds because there's more stuff in it. And what does a slower build imply? For me, there's one part, and that is, if your build is slow, it's harder to work test-driven. It's not impossible, but it's harder because you need to wait longer all the time. And people and developers hate waiting, except if you want to get your coffee, but you don't want to get your coffee every 2 minutes. So there's a tendency to be less test-driven if you have slower builds. And being less test-driven, for me, implies that usually you build a feature and then you write 1 or 2 tests afterwards to have enough test coverage, something like that. So the code coverage might be okay, the formal test coverage might be okay, but there's still probably the quality of what you're doing is not that good. Have a look at the whole TDD movement. There is a good reason to be test-driven in your development and not to be super slow and write just a few tests. So for me, the slower build leads to less test-driven, leads to increased risk of higher failure rate. Not that cool. Another part, if your build is slower, probably your overall pipeline is slower of your CI/CD, obviously. If their stuff is slower, the whole team processes get a bit slower. It's just 1 or 2 minutes, maybe it's 5 minutes, maybe it's 10 minutes more, but they sum up a lot. And people start to switch contexts and just wait for stuff and do something else in the meantime. So overall, stuff is getting slower than it needed to be. And why might that be a problem? Because your actually lead time to bring changes live increases. And you want to bring your changes live fast. Okay. Second part here, another risk, deployment frequency. There's the obvious part. If the build is already slow, the deployment is slow. Yeah, okay, but this might be the small thing because those 5 minutes more might not be the big factor here. But I assume a lot of you have worked with monoliths, and it's most of the time not the difference between does it take 2 minutes or does it take 3 minutes. It's more the typical monolith is something like, oh, it will take an hour till the whole thing is built. And then you finally see your test failing or something. What do people do who work in such an environment? I have a few assumptions for you that you might verify for yourself. One is, if the deployment is slow, you tend to do bigger increments. Because if the whole deployment flow is such a big overhead in your work, you just avoid it by doing big changes. It's more efficient in the end. You don't have to wait that much. But the risk of bigger increments for me is there's a risk of doing more mistakes, so an increased failure rate. It takes longer for every part of that feature to go live, so increased lead time for change. one more thing, if you do bigger increments, and we're talking about a monolith with multiple people working on it, there's increased coordination between teams because more stuff gets done in parallel. And coordination takes time. So the lead time till your change get live takes longer. I have seen, it's not always true once again, but I have seen, there's even one thing, if builds take very long, at some point people start to organize themselves by scheduled deployments. Like we deploy every morning or 2 times a week or once a month, depends on your company and whatever. But in all of those cases, if you schedule, obviously even more coordination, even higher lead time for change, because even if you're done, you have to wait for the next deployment. And one more thing, in case of a problem, you have to wait for the next scheduled deployment to actually fix it. So your time to restore your service in case of a bigger problem also increases. So there are quite a few tendencies. I think none of them sound super good from the outside. Okay, so let's get back to that picture. Hope you were able to follow me why I see that in monolith there are a few problems. So you want to go to the bit smaller executables. Got it. Let's go more to the left side. But if you take the picture how it is now, why not go to the extreme left? If you just do super small things, you obviously avoid all the problems on the right side. Okay, and now let's not do the guessing game. There's also problems if you go to the extreme left. And there, I want to mention 2 of them. So it's getting clear why the sweet spot is somewhere in the middle and not on the extreme left. Yeah, the first one I want to talk about is the faster computation within services. And the second one is the independence of change. So there's one thing about going in the direction of microservices or nanoservices, and that is not all your code runs in the same executable anymore. That's desired. That's what we wanted. But it also means those executables will have to talk to each other at some point in time. And it doesn't look like a big problem in the beginning. But if you go enough to the extreme, actually you will find out that there is a bit of a timing problem inside here. If all the stuff you want to do for your customer always need network communication between your super small services, at some point, this network communication is your bottleneck. And with bottleneck, I don't mean like it's bottleneck in case of small, but it takes time. And it's hard to optimize network speed, especially if we're talking about cloud. So yeah, there's something true about this method calls within one executable are faster, very much faster. So if you're splitting up domains and services into extremely small parts, actually this computation speed can get into a relevant topic. I've been there, I've seen that, and I was surprised that it can still be a problem, but yes, it can still get a problem if your services are getting too small. Another thing for me that's probably even more relevant than the computation speed is the independence of change. And this is also a lot about not only about the size of the executable, but also about where to cut. And it is about features that touch multiple services. In a monolith, it was always easy. Whatever you wanted to do is in that monolith, and there might be different files, but all in the same thing. But now, if it's split up into multiple features touching multiple services are actually a thing. And here we go into how do we do that? It's not that easy anymore. One thing might be between different teams, coordination. Second thing, how do you deploy multiple services independently where the features depend on each other? So you actually have to start thinking about cases in between. Like one service has a new feature, the second does not yet have, then the second get introduced, all good, but it's now 3 states you need to care about and not only, yeah, I do one change and one deployment. So there's coordination coming in now. Coordination in terms of how to do change, coordination in terms of talking to each other. And also, change might imply refactoring in case of service boundaries. Like you might find out that your services were cut in the wrong way. And for this case, it's the same. It's actually harder to change than just to move a file within the monolith. It's possible, it's totally possible. And if you did the cut right into the right sizes, and if you didn't put it all into super small pieces, it's probably not a huge topic, but you might run into that. So going back to that picture, there are 2 problems on the extreme left, and I would say it's more on the extreme left. So probably your sweet spot in the middle is big. And there are the 3 on the right side that we had. So what our industry did for the last 10 to 20 years is moving from the right to the middle, moving a bit to the left, too far to the left, finding out that it was too far to the left, and now everybody's still searching for the sweet spot, and that totally depends on your domain and your problem, actually. Because for small things, the answer might be far more on the monolithic side. For really huge companies like Netflix, it might be far more on what we perceive as nano. For companies like Mr. Specs, where I work for, the answer is more in the middle, because we're neither super small nor super big in terms of comparison to Netflix. Next part. I promised you that I want to talk about this. Why should I invest money in your request for change? Because that whole thing so far was IT people talking to each other. Developers love to complain, poor monoliths, all that and all that thing. But the critical part is, why does my complaint actually have any effect for the business? Because if it's just me telling, it doesn't feel good, I don't want to work like that, why should business managers care about it? Except that they probably want to keep the people. But the interesting part is there's actually more in it. And this is why actually having problems with a monolith might be worth changing. And here I want to go for one book that you should read, and and that is Accelerate. So the book by Nicole Forsgren and Jess Humble and Jean Kin. I put one quote here onto that slide. We found that where code deployments are most painful, you'll find the poorest software delivery performance, organizational performance, and culture. What do I like about this quote? It's just the part about the code deployments. There's other parts also talking about other stuff than deployments. But it is a very good summary of what I found. And it is that the stuff that I talked about has influence, and you find it here, on software delivery performance, organizational performance, and culture. And with organizational performance, there's actually business behind. And with business, there's money behind. And also business managers care about earning more money. So what Forsgren and co. did in their book, and what is also behind the Dora project by Google, is there's investigation going on if there's actually a relation of IT metrics to business performance. And the answer is yes, there is a relation, and there's good science by now that this relation exists. And the one project that you probably heard about, and if not, you should know about, are the Dora metrics by the Dora project. So was DevOps project. And they found 4 metrics that are directly, scientifically, at least correlated, not by cause, but correlated to business performance of IT companies. And those are 4 things. Deployment frequency, how often an organization successfully releases to production. I have talked about deployment frequency, like it was mentioned with the build frequency and the deployment frequency. There are correlations. So from Monolith, you might actually run into a bad deployment frequency. The second metric that is important is the lead time for change. They define it as the amount of time that it takes a commit to go into production. So the full array of reviewing, testing, and release process. If you go for the Dora metrics, you find that actually everything below 1 hour is cool. Most monoliths that I've seen, it's more in the range of days. So there's room. And yeah, in the arguments that I showed you, I purposefully already introduced the term of lead time for changes. There is the correlation. You were able to find it, hopefully. Last one, the second to last one, also an interesting one, is the change failure rate, the percentage of deployments that actually cause a failure in production. Failure here means customer relevant failure, not the button has the wrong color, but customers cannot buy stuff. So the real failures. Also, I've talked about how build and deployment can influence this. And the last one is the time to restore service. So how long does it take you to recover from a failure? This is a DevOps project, so it's obviously especially important here, but also it's actually interesting for you because this is a critical metric in case something failed and stuff will fail. So how long does it take you to recover from that? Is it a full, next week our monolith has its next deployment cycle and we can do a bug fix then? Or is it more, yeah, okay, it is this and that service, let me hit the revert button, give me 5 minutes. There's room in between. So I hope with those metrics, you should be able to talk about your monolith and discuss if it actually has a business relevant problem here, or if it is just your own perception of a problem. But most of the times, actually, the problems that you can find are business relevant problems, and you might be able to discuss them on such a level. I promise to also give a few hints about how to approach change in case you want to change stuff. I don't want to go into super low detail on that, but I want to give you 2 hints in case you're going into that topic. The first hint is actually something specific for this conference right now. Sam Newman is talking, I think, at the right time as I'm doing, and he wrote a book about monoliths to microservices. Have a look there. I like that book. And the other one that I want to give you is the Strangler pattern. You already see it. It's once again a quote by Martin Fowler, who wrote about that one. You will find the resources a few slides later. So what's the Strangler pattern? It is pull a small piece out and let it grow over time. That's a very short summary. I put one example below of what could be a monolithic application, having a lot of domains. And Strangler pattern is don't do a big bang full rewrite of that whole thing. Don't even try to. But what you want to do is take one domain. In my example, it will be the X. Take a piece of it, if possible, and move it out. And let those two applications now talk to each other if they need to, because you moved out a small part. And then over time, move more of domain X out, and then the full domain. That's how you can basically move one domain at a time. You can, in theory, even do it with multiple domains. Yeah, sure, if multiple teams are working on it. But the pattern, what it wants to do is don't do the big rewrite, big bang, big risk thing. That takes forever. But move out. The first part will be small and hopefully doable in weeks, and then iterate by moving more and more stuff. And over time, on the left side, in the monolithic application, there's basically nothing left. Example, we have that situation at Mr. Specs. For years, a monolith was the perfect solution to all problems because it was just the right size to solve everything. In case you have never heard of Mr. Specs, it is an online, Europe-wide eyewear seller. So online means, in that case, omni-channel, online and in stores in a few countries. And our web application is a monolithic shop application. That was totally fine for years because it wasn't too big. It was just the right size for the amount of people working on it. But with the company growing, the monolith is not the perfect solution anymore. And what we are doing is trying to move out. We decided that we want to go for the products to move out of the shop. And the first step that we decided to strangle was, let's move out only the part, the front end of the product, and only the browsing, and everything else stays in the shop for now. That was the first step, already took quite some time, but proved itself working. It's mostly done, it's fine. And then in the second part, and before going to the second part, I'm sorry, the whole backend is still in. So it really just moves the front end, just moves the small part, strangle step by step. Second step that we did, then let's move the backend out as well. And now this looks familiar from the graphic 2 slides ago. Move one part out, let everything else stay in that monolith for now, and try to move more and more of the products out of the shop. As soon as we are done, we are not yet done, we can talk about other parts of the monolith. Why did we do that? And why were we able to convince managers? In our case, there were actually 3 parts. The application was slow because the monolith wasn't that perfect in some cases. So we were able to convince people by page speed. And page speed is SEO relevant. And SEO is business relevant. Nice, very nice. And the second part, also relevant here, is actually the discussion went a lot around the Dora metrics, that we need to get to a higher speed, smaller, faster changing company by improving on those metrics. And for the one strangle that I just showed, how? First, do a small, in our case, 2-week spike to prove that it's possible to move that part out. And then with full team, with full-fledged, go the whole way. That's how. But already the 2 weeks needed to prove that by business metrics and SEO, it was the right way. And actually, it was able to be proven here. Yay! So you were able to follow me through my whole talk, I hope. So let me summarize what I just talked about. We found out that the problem with monoliths is not that it's executable, but the monolith is getting a problem if it's getting too big. And we discussed what might be the parts of too big, what might be the problems here. I hope that you were able to take a few of those arguments for you and think about if it applies to your monolith. On the question, why should I invest money? in the request for change and getting out of the monolith. I hope to have helped you in your next discussion with your business manager with the book Accelerate and also with the Dora project, that both prove in a scientific way that there is actually a correlation and a need for change. I have given you at least 2 hints how this change could be done. And our one example, how Mr. Spex is doing it right now. And now, obviously, I had a few resources. So here is the list that the first one is the book and all the other stuff are relevant articles. And I would be open for questions now. Oh, one last hint. I'm not on Twitter. That's why I put no Twitter handle anywhere, but you can find my name on LinkedIn.
Okay, let's see. Let's see if we have any questions on the topic. I reminded people online to do that before you finished your session. So let's see if we will have something here. What about the live audience? Yes, we do have a question right in front. Here you go. Take the microphone.
Thank you, Anja, for your talk. It was very relevant to one of the problems I am also experiencing currently at work. And a question that I have, so with all those Dora metrics and ways to persuade management, when it comes to the management asking you, okay, very well, we're going to invest, we know how much developer hour costs, we're going to invest this many developer hours, how can we be sure that the benefits we get as a result outweigh the cost of the change? So how essentially can you quantify all those cool metrics into money?
Oh, that's a hard one. If I would have a full answer now for you, I would probably not be at a conference, but earning millions of money. But yeah, thank you for the question. Honestly, I don't have the full answer how to exactly quantify that, because yeah, the quantification part is the critical part here. As soon as you start calculating with developer hours, I have no fixed like formula for you to help you on that. I'm sorry.
No worries. So, thank you anyway. Okay, do we have any more questions in the audience? Not much, and I'm checking online. It seems that nobody had any questions so far. Anyway, so that's gonna be that. Thank you very much for joining us. Thank you very much for I don't know, being a part of 10th Build Stuff this year. Did you know that we have an anniversary this year?
Yeah, I did. I saw that, and I was especially proud that I'm able to talk here this year.
Okay, we're very happy to have you. So that's all. Give a round of applause. I don't know why I'm stuttering all the time. And thank you very much for joining us.